Now, okay. What is the next? Make separate this. What is the next? Synonyms. Okay. But this is synonyms. What is synonym is? A synonym is another name or alternative name for a table or view. Another name or alternative name for a table or view. We can give another name to the table, so that another name is called synonym. Okay, na? We give another name to the table, that another name is called synonym. Now, let's see why we give another name to the table. Okay, na? Suppose here table names are what? EMP, DEPT, like this. Table names are short. But if you go to real-time projects, table names will be lengthy. Some table names will be lengthy. You want to store employees' data, but if you take the table name EMP, they don't accept. Okay, na? Table name should be descriptive. You have to take some descriptive name, like you have to take the table name like this: employee, what's it? Personal, what? Details. Okay, na? One table is like this: employee, personal details. You have to take the table names like this. Next one, employee, what? Contact details. Employee personal details, employee contact details, like this. You have to take the table names like this. If you take the table name EMP, DEPT, like that, they don't accept. Okay, now you have to follow the standards when you are giving the name to the table. So table name should be descriptive. But if table name is lengthy, this table name is lengthy, no? If table name is lengthy, then what is the problem? If table name is lengthy, what is the problem? Problem is for developers, because developer has to type number of characters. Who write the queries? Developer write the queries. While writing the queries, he has to type number of characters. So then it is difficult for developer. Then what SQL Server says, if table name is lengthy, give some simple and short name to the table, like EPD. Give some simple and short name to the table. EPD. Here what's that? ECD. Employee contact details, employee personal details, short name. So wherever you want to use this table name, we can use this simple and short name. Just give some simple and short name. Instead of using the table name, use this simple and short name. What this simple and short name is called? Synonym. So when we create synonyms if table name is lengthy. Okay, then so like create synonyms if table name is what's it? Lengthy. So create synonyms for lengthy table names. Then create synonyms for lengthy table names. Table name is lengthy. Now, next, how to create synonym. Okay, then you have to follow this one. What that is? Create synonym name for table name. Create synonym name for table name. You have to follow the syntax. Create synonym name for table name. Example. Okay, na? Example. Then create synonym E for EMP. But here EMP table is there, but actually not required. For EMP table, we don't need to create synonym because for EMP table, we don't need to create synonym because it is short. Okay, na? Then when we create, when name is lengthy, then create. But just for example, I'm creating the synonym. Now let's see here. Create synonym. Okay, na? Synonym is created. Next, after creating synonym, okay, then instead of using table name, after creating synonym, instead of using table name, use synonym name. In which queries? In select, insert, update, delete queries. After creating synonym, instead of using table name, use synonym name in select, insert, update, delete queries. No. Yet nothing is case sensitive. No one is case sensitive. Okay, now then. So like now you want to see the EMP table data. Then you want to see the EMP table data. Then what? Select star from E. Select star from E. If you run select star from E, then what this query displays? This query displays EMP table data. Yes or no? Then this query will display EMP table data. Select star from E. Showing EMP table data. Yes or no? Next. Otherwise, not only select statement, we can use it in update command also. Not only select, insert, update, delete, any query. Update E, set salary equals to 2000. Salary equals to 800, where employee number equals to 100. Employee number is 100. Salary is updated with what's that? 800. I'm updating the salary with 800. But in this update command, I'm using synonym name. I'm using synonym name. One row affected. Now see the table. Select star from E. See the table. So 800. Yes or no? Understood? Then select star from EMP. You see the EMP table also 800. Yes. So instead of using table name, use synonym name. No. Sir, query is lengthy. Query is lengthy. Then what you do? Query is a lengthy query. I want to repeat that query number of places. Then there is no, you cannot create synonym. See that. You can create synonym for what? Table name or view name. Query is a lengthy query. My query is lengthy. I want to write that query number of places, number of applications, number of programs. Then what to do? What is the solution? No? How can you give the alias for query? Query. You know that. Create view. Create what, sir? View. Create view was create view v1 as query. You write query. You given a name to the query now. This query contains 100 lines. Then this query contains 100 lines. You are giving a name to this query. What is the name given to this query? v1. Whenever you want to use this query, then select star from v1. Yes or no? Query is lengthy. Create view. Table name is lengthy. Create synonym. Okay, na? That's all. This is the only purpose. Simple. Nothing more than this. Now, suppose here a question asked like this. What is that is? They given 3 commands. Create synonym, E for EMP. This is one command. Next, another command. Select star from EMPE. This is another command. Third one, SP underscore rename EMPE. Then they asked, explain the difference between these 3 commands. Explain the difference between these 3. In the first case, what is E? Synonym. In this case, what is E? What is this E? Alias. Is alias now? Here, what is this is? Rename. This is synonym. This is alias. This is rename. First, tell me what is the difference between synonym and alias. What is the difference? Synonym and alias. Alias is permanent. No, alias is temporary. What is the scope of this alias? Only in this query. Only in this query. Can we use this name in another query? No. Okay, na? This is temporary. But what is the synonym? Permanent. Synonym is what? Permanent. You are giving another name to this MP. This is permanent. Can we use this in another query? Yes. Is alias stored in database? No. Synonym is stored in database? Yes. Because it is starting with create command. Something starts with create command stored in database. So it is a database object. But alias is not database object. Sir, only in this query, you want to give another name to the EMP. Then only in this query, you want to give another name to the EMP. Then alias. But I want to give another name to the EMP in within the database. Then synonym. Okay, na? I want to give another name to the table. Like permanently, I want to give another name to the table. Then synonym. So, like, what is the difference between synonym and alias? So synonym is what? Synonym is stored in database. Alias is not stored in database. Synonym is what? Permanent. Alias is not permanent. Synonym is permanent. Alias is not permanent. Synonym and scope of the synonym is what? Up to the, like what? Up to the database. What is the scope of the synonym? Up to the database. What is the scope of the alias? Up to the query. Only within that query we can use. Okay, now next one. But what is this is? What is this is? But in these two cases, in these two, is original table name is changed? In these two cases, is original name EMP table name is changed? No, you are not changing the table name. You are giving another name. Yes or no? Giving another name is different. Changing the table name is different. In these two cases, you are not changing the table name. You are giving another name. But here, what? Changing the table name. So the original table name changes from EMP to E. So what this command changes? This command changes what's it? Changes the table name, what's it? EMP to E. But here in these two commands, it is not changing the table name. You are giving another name, but in this command, you are changing the table name. That's all. Okay. So then, now, so if you want to see the list of synonyms, select star from what? Sysdot what's it? Synonyms. Like what is the synonym name? E. It is created for which table? EMP table. Name of the synonym is E, and it's created for which table? Right. Okay, na? This is the command to see the list of synonyms. Command to see the list of synonyms. So if you want to see the synonyms list, like list of synonyms created by user, this is the command. Now, how to dropping synonym? Drop synonym name. This is not Oracle class. This is not Oracle. No, that is Python. No. Yesterday they came too. Okay, na? I said this is not. This is SQL Server. They said yes. Okay, na? But today they didn't come. Actually, they are not SQL Server. They are not our class. Hmm? So drop synonym E, drop. Anything created with create command can be dropped with drop command. Okay, na? Then. Okay, na? Then. How to see the list of tables? Tables list. Views list. Tables list. View list. Synonyms list. To see the tables list, then information, views. How to see the list of views? Information underscore schema dot views. Okay, na? Tables. Information underscore schema dot tables. Okay, na? Synonyms. Information underscore schema dot synonyms. Sequences. Information underscore schema dot sequences. Okay, na? This is how to see the list. Next. One is left. What that is? Indexes. Then. So what is index? What for indexes are created? Okay. What is index and what for the index is created? So index is mainly created to improve the performance of what data accessing. Index is mainly created to improve the performance of what? Data accessing. Okay, na? So, like 1 second, suppose you run a query. You submit this query to SQL Server. Select star from what's that? EMP, where salary equal to 3,000. You submit this query to SQL Server. When you submit this query to SQL Server, then, but you will get the output in seconds or fraction of seconds. Yes or no? You are getting the output in seconds or fraction of seconds. Yes. Then run this yet. So execute this query. Then you'll get the output. Immediately you got the output. But why? Because here our table contains how many rows? 14 rows. Our table contains how many rows? 14 rows. In 14 rows, finding the employee salary equal to 3,000. It has to find out the employee salary equal to 3,000. In 14 rows, finding this records is what? Like faster. It will not take much time. It takes seconds or fraction of seconds. But if you go to real-time tables, the table contains lakhs of records. Here, our table contains only 14 records, but real-time tables contains what? Lakhs of rows. In the lakhs of rows, finding this record is time taking or not? Yes. Okay, na? Door close. Finding the salary equal to 3,000 is what? Time taking. So SQL Server takes more time to find the records. Suppose assume SQL Server is taking half an hour time to find out the records. But his users will wait for half an hour? No. Users will submit the queries. They wanted the response in seconds or fraction of second. They can't wait for minutes time. If SQL Server is taking more time to execute the query, then we need to improve the performance of this query. Yes or no? So to improve the performance of this query, then we use one object. What that is? Index. Okay, na? But here you running the queries on table of 14, 15 rows. But if you go to real time, you run the queries on tables contains millions of rows, lakhs of rows. So their queries takes what, sir? More time to run. So you need to improve the performance of query. For improving the performance of query, we use what? Index object. Okay. Na? So what is the main purpose? Improving performance. Then, so what is index? Index is a database object created to improve the performance of what? Data accessing. Database object created to improve the performance of data accessing. So to improve the performance of data accessing the data. Okay. So an index in index in SQL Server is similar to index in textbook. Okay, na? Index in SQL Server is similar to index in textbook. Every textbook comes with index. Yes or no? Suppose, assume there is a textbook, SQL Server textbook. The textbook contains 1000 pages. In that, index is not there. The textbook contains 1000 pages. There is no index. I'll give the textbook to you. I'll ask, find out the joins topic. Then what you do? The textbook is given. I'll ask, find out the joins topic, but there is no index. Then what do you have to do? You have to go to each and every page. You have to scan the complete textbook until you find the joins topic. Time taking or not? Yes. Okay, na? In 1000 pages, joins topic is there at 900th page. Then you have to go through the 900 pages. Takes more time or not? Yes. Suppose if index is there, then just go to the index. In index, topics arranged alphabetically, ascending order. So find out the joins topic. The topic is associated with page number. You go to that page directly. Finding the topic is faster or not? Yes. However, a textbook index works same way database index works. But the difference is, in textbook you search for particular topic, but a database search for particular record. In textbook search for particular topic, but in database search is for particular record. Salary equal to 3000, name equals to Blake, like that. Okay. So that is what how index works is. Then, so index in database is similar to index in textbook. Index in database is similar to index in textbook. Okay, textbook. In textbook, using index, a particular topic can be located fastly. In textbook, using index, a particular topic can be located fastly. Next one. In database, using index, a particular record can be located fastly. Okay, now let's index next. Then and indexes created on, you create indexes created on what's that? Column. Views created on, views created on query. You create the view on what's that? You create views on query. Okay na? And you create index on what? Columns. Like, and synonyms created on, synonyms created on what's that? Table. Okay, then synonyms created on table, and indexes created on what's that? Column. And that column is called, and that column is called index key. That column is called index key. Okay, you create indexes on column, that column is called index key. Okay, next. So then, but on which columns you create the index? On which columns you create the index? How you decide? That depends on what's it? That depends on, for example, this is the query. See, in my application, like in my application, most of the queries are based on salary column. In my application, most of the queries based on salary column. So better to create index on salary column. In banking, like most of the queries based on what? Where condition. Where condition is based on what's that? Account number, because maximum fetching the record from table is based on account number. Yes or no? So here where condition is based on what? Account number. Okay na? So better to create index on account number. So on which columns you create? The columns which are frequently accessed in where class. The columns which are frequently accessed in where class. Okay na? The columns which are frequently accessed in where class. And another one, the columns which are used in join operation. Columns which are used in join operation. Suppose, for example, then in my application, I join this MP table and what's it? Department table. And most frequently I join these two tables based on the department number. So better to create index on, better to create index on department number. In my application, frequently I join these two tables based on the department number. So better to create index on department number. So on which columns you create index? Columns which are frequently used in where class, and columns which are used in join operation. Okay. So these are the like what columns recommended for index. Then, so indexes created on columns, one, like which are frequently accessed in where class, and which are used in join operation. Okay, na? Then which are frequently accessed in where, which are used in join operation. Next one. What are the different types of WhatsApp indexes? Mainly two types. One is non-clustered index. Indexes are mainly two types. Non-clustered. One is simple. Non-clustered, again three types. Simple, composite, unique. Second one, clustered index. There are two types: non-cluster indexes, cluster indexes. Non-cluster and cluster. Ah, what is that is? First one, like we'll see what is non-cluster, what is cluster. After going to cluster, I'll give the difference. What is non, what is first. So simple non-clustered index. First we'll start with simple non-clustered index. When index is called simple, if you create index on single column, it is simple index. If you create index on multiple columns, it is called composite index. Okay, then so if index created on what single column, then it is called simple index. If you create index on single column, it is simple index. If you create index on multiple columns, it is called composite index. Okay, then example, like let's see. Example, I want to create index on salary. I want to create index on what's that? Salary. How to create? Create index I1. Create index I1. Every object same syntax. Create table, table name. Create synonym, synonym name. Create view, view name. Okay, na? Then create index, index on which column? I said create index on columns. On which column? Salary. Salary belongs to which table? EMP table. So you have to say EMP sal. So you create index on salary, but the salary column belongs to which table? EMP table. So you have to create like this. Then, so index is created. Okay, na? Index is created. Then created successfully. One index is created. But after creating this index, what happens? How SQL, how performance is improved? Okay, na? After creating index, what happens? After creating, after executing this command, internally one structure is created. What that structure is called? That structure is called B tree. After executing this command, internally one structure is created. What that structure is called? B tree. What is B tree stands for? Balanced binary tree. What is B tree stands for? Balanced binary tree. With the help of this balanced binary tree, SQL Server locate the data fastly. Okay, na? When that binary tree is created, balanced tree is created after executing this command. Okay, then how the tree looks like. Okay, then so anywhere, anything. Now, so let's see how that tree looks like. Then So it will be something like this. The tree will be like this. Okay, na? When this structure is created, this structure is created immediately after executing this command. Okay, na? Then so first you understand this tree. If you understand this tree, then you'll understand how index improves performance. Like let us say this is index. Okay, na? Then in this, each one is called one node. Each one is called one node. This is one node. This is one node. This is one node. This is one node. Each one is one node. And what these nodes are called? These nodes are called leaf nodes. These nodes are called leaf nodes. And what is this node is called? This node is called intermediate nodes. What this node is called? This is called root node. The first one in the tree is called root node. Middle one is called intermediate. Last nodes are called leaf nodes. So this is the structure of the tree. Okay. Then now let's see this. First, understand this leaf nodes. Each leaf node contains, like you created index on what? Salary. Each leaf node contains salaries plus address. Leaf node contains what? Salary plus address. So like what this is, let's say assume this is what? Salaries. Sir, salary 16.35 means assume salaries per hour. Salary per hour $16, $35, $86, something. Salary per hour. So leaf nodes contains what, sir? Salaries. Okay, na? Next, every salary is associated with what? Address. The salary, every salary is associated with address. Address of the record. Because where the record is stored? Record is stored in what, sir? Is index stored the record? Index stored the record? No. Index stores only salary. Because you created index and what? Salary. It stored salary and address. Address of the actual record. Where is the actual record? Actual record is stored in table. That record address is stored here. Like in textbook, topic and page number. No? Topic and page number. Here salary plus address. Okay. So here 16 row ID. Okay, na? Row ID means leave it. Address. Next one 35 address. 65 address. So all these leaf nodes contains what? Salaries plus addresses. And next, you take the root node and intermediate nodes. You take the root node and intermediate nodes. And every root node and intermediate nodes contains a left pointer and a right pointer. Left pointer and a right pointer. Left pointer points to the values less than or equals to this 122. Left pointer points to the values less than or equals to 122. Right pointer points to the nodes values greater than 122. Left pointer points to values less than or equals to 122. Right pointer points to the values greater than 122. 122 left side. What is left side? What values comes left side of 122? Huh? 65. Like see that. 65 left side. 65 left side. What are the values? 16, 36, 35, 65. Like 65 right side. 65 right side. What are the values? Values greater than or equals to, sorry, greater than 65. Left side what's are? Values less than or equals to. Right side is what? Greater than. So 122 right side. What that is? 136, 151. All these values are greater than 122 or not? Yes. 136 left side is what? Less than or equals to 136. 136 right side greater than 136. 151 right side greater than 151. Yes or no? So what this is called? This is called tree. So this tree structure is created. When this tree structure is created, after executing create index command. Okay, then so let's once again, suppose you take our example, you take our example. See, I'm taking emp table. Salaries are like this. First employee's salary is what, sir? Suppose 2000. Next employee's salary is 5000. Next employee's salary is 3000. Next employee is 1500. Next employee 4000. Next employee is 3000. Next employee 2500. Like this. Salaries are like this. So total, then how many values are there? Like 8 values. I've taken 8 values. 1, 2, 3, 4. 1, 2, 3, 4. Total how many values? 8 values. Suppose you executed the command. If you execute the command, one tree structure is created. I'm just taking the tree structure like not exactly like this, approximately like this. So 3000 and 3000 left side is what, sir? 2000. 2000 left side is what, sir? 1000 star. Next one 1500 star. Next one 2000 star. Left side comes what values? Less than or equals to 2000. 2000 right side. 2000 right side. What? 2000 right side. 2500 star. Next one 3000. 3000 comes left side of 3000 or right side of 3000? Left side. Less than or equals to. Yes. So 3000. 3000 star comma star. Why 2 stars? What is star means? Star means address. Star means address. Why 2 stars? Because there are 2 employees earning 3000. How many employees? There are 2 employees earning 3000. The 2 addresses. So maybe one address is this record, one address is this record address. Okay. The actual records are there in the table, but index contains only salaries plus address. And 3000 right side. 3000 right side is what? 4000. And 4000 left side. 4000 left side is what? 4000 star. 4000 right side. What? 5000 star. So this is the tree created after executing this command. Okay, na? Understood or not? Then. So now, like, but this I'm not taken arrows. Okay, na? Here it will be like this, but I not taken the arrows. Okay, na? Then now when SQL Server will use this index, SQL Server will use this index whenever, listen, whenever you submit the query, in that query where condition is based on what, sir? Salary column, then SQL Server will use this index. Suppose I given salary equal to what? 3000. Okay, na? Then I given salary equal to 3000. When you submit this query, first SQL Server checks whether any index is there on salary or not. Index is there on salary or not. Suppose index is not there. If index is not there, then it goes to, if index is not there, it goes to table. It goes to table. If index is there, it goes to index. If index not there, it goes to table. If index is there, it goes to index. Suppose assume index is not there. If index is not there, it goes to table. Then how it will set, how it will check? So it go to the first one. Salary is what, sir? 2000. Condition false, not selected. Next 5000, false. Next 3000, true, selected. Next false, false, true, selected, false. Then what it checks? It checks all the rows. If table contains 1 lakh rows, it has to compare. If table contains 1 lakh rows, it has to compare all the 1 lakh rows. Time taking or not? Yes. Okay, na? So suppose assume index is there. Index is there. If index is there, then it goes to index. So index, what is the given value? 3000. 3000, 3000 is compared. Then equal or less than, go to left side, greater than, go to right side. So given value is 3000. Root node is also 3000. Equal, then go to left side. So next 2000. 2000, 3000 is compared. So 3000 is what? 3000, 2000 is compared. So 3000 is greater than 2000. Then go to right side. Go to right side. Now there is a leaf node. It has come to the leaf node. So 2500. Condition false. Next 3000. Condition true. Condition true. Then what it will do? It will take this. What is this stars? Addresses. It take these addresses and go to the table, fetch the records from the table. Once it knows address, it will directly go to that address and fetch the records from the table. It doesn't need to search each and every row. Understood or not? Then. So salary equal to 3000. So 3000, 3000 is compared. Then go to left side. 2000, 3000 is compared. Go to right side. So 2500 false. 3000 true. And take this address and go to the table, fetch the records from the table. So tell me how many comparisons here? How many comparisons? 1, 2, 3, 4. 4 comparisons. In 4 comparisons, you are able to find out salary equal to 3000. But if you go to original table, how many comparisons required? 8 comparisons. If it is index, how many comparisons? 4 comparisons. That means number of comparisons are reduced to half. When number of comparisons are reduced to half, performance is double. Okay, na? Sorry, in any query, either it goes to left side or it goes to right side. That's all. That means what? Searching is divided into half, not the complete table. Yes or no? What? Searching is divided into half. Either it will search in left side or it will search in right side only. Understood or not? So this is how it improves what? Performance. Okay, then. So when we submit the query to SQL Server, when we submit query to SQL Server, it uses following methods to find the record. When we submit query to SQL Server, it uses following methods to find the record. What is one method is? One method is what? Table scan. One method is what? Index scan. SQL Server uses following methods to find the records. One is table scan, one is index scan. In table scan, in table scan, what? In table scan, so SQL Server scans what's it? In table scan, SQL Server scans complete table to find the record. Okay, na? In table scan, SQL Server scans complete table to find the record. Then next, in index scan, SQL Server scans what? Does it need to scan the complete table? No. So SQL Server scans what's it? What? Half of the table, either left side or right side. Now either it has to check left side or it has to check right side. That means half of the table. Scans half of the table to find the record. Which is faster? So index scan is faster than table scan. That's it. Okay. Okay. Then. So not only this query, like select star from EMP where salary equals to 3000. For this, it will use what, sir? Index scan. Not only this query. Suppose I write something like this. Then salary greater than or equals to 3000. For this query also, it will use index greater than or equal to 3000. Okay, na? Salary greater than or equal to 3000. Okay, then. Now, so if you see this here, leaf nodes are interlinked. There is a interlink here. This one was leaf nodes are what? There is a interlink between these nodes. One leaf node is interlinked with another leaf node. Okay, na? Then let's come to this one. What is the given query? Salary greater than or equal to 3000. Now 3000 is compared. Then value, what is the value? 3000. 3000 is compared. Then go to left side. 2000 is compared. Go to right side. 2500. No. 3000. Yes. So 3000. Selected or not? Yes. And it also select all the nodes right side to this 3000. So once it comes to 3000 is selected, and it also select the nodes which are right side to this 3000. The nodes which are right side to this 3000 are what? Greater than 3000, because you're asking for greater than or equal to 3000. Na? So it select 3000 and also select the nodes right side to this 3000. So how it goes to next nodes? How it goes to the right side? How SQL Server go to the right side? Because there is a what? Interlink. See, one node is interlinked with another node. So then this is, once it finds 3000 is selected, and it go to the next nodes. Select whatever, 4000 is selected. Next, go to the next node, 5000 is selected. Okay, na? Without any comparison. Without any comparison, it selects all the nodes right side to this 3000. So take these addresses, go to the table, fetch the corresponding rows from the table. Okay, understood that. Now next, what is this is? This is also uses index scan. Suppose I am writing a query, select star from EMP, next EMP, where salary less than or equal to 3000. Then salary less than or equal to 3000. Then what? So same thing, 3000 is compared. Then go to left side. 3000 is compared. Go to right side. 2500 selected or not? Yes, because you are asking less than or equal to. 2500 is selected. Yes. 3000 is selected. Yes. It selects all the nodes left side of 3000. The nodes which are left side to this 3000 are one less than 3000. Yes. So this is selected. This is selected. This is selected. And it take these addresses and go to the table with the records from the table. Okay. Then. Sir, what is the here? Like skipping what's it? Avoiding what? What we are doing with the help of index, we are avoiding row by row comparison. What we are avoiding? Row by row comparison. Row by row comparison is what? Time taking. Okay, na? Then. So instead of doing row by row comparison, So we are using index. Now, suppose, for example, I write a query like this: select star from what? Select star from EMP, where ename equals to Blake. Okay, na? When I submit this query, is Oracle use index? Oracle use this index? Oracle use this index? No. Okay, na? Because why? Index created on salary, where condition is based on ename. So it will not use index. It will use table scan. When it will use index, only when where condition based on salary column, then only it will use index. But here where condition is based on ename column, so then it will not use that index. If index is there on ename, then it will use that index. Okay. Then next, this is my query. What is my query? Is select star from EMP. Then no where condition. Select star from EMP. That means what do you want? You want all the data. When you want all the data, is SQL Server use index? No, it will not use index. It will use table scan. You want to read the complete textbook. If you want to read the complete textbook, index is useful. You want to read the complete textbook, boss, is index is useful to you? No. When you want to read a particular topic, then index is useful. Here you want to read the complete, then index is not required. Yes or no? Okay, na? That's it. So this is where like index is useful, where it will not use index, it will use table scan. Where condition is not based on index column, where condition is based on other than index column. So next, there is no where condition. That means you want to see the complete table data, then index is not useful. Sir, okay, that's all. So this is index, and here this is created on how many columns? One column. And what this index is called? Simple index. If you create index on multiple column, then it is called composite index. So next one, composite index. If index created on multiple columns, then index is called composite index. Then how to create index I2 on EMP department number, comma, job. Create index I2 on EMP department number, comma, job. What this is called? Composite index, because you created on two columns. Sir, how you decide I should create on salary, I should create on department number, I should create on department number, comma, job? How you decide? It is all based on where conditions. All based on what? Where condition. According to the where condition, you create the index. Okay, na? One user is one client. Client is saying that, boss, this query is running slow. Okay, na? So because of this query, his application is running slow. Then create index on salary and test. This query is running slow. Then create index on salary. This query is running slow. Then create index on ename. So how you decide? It depends on where conditions. Now, So run this, create this. None. So index is created. So what this is called? Composite index. Okay, na? Huh? None. Now, what is the next? Hmm? So, like when SQL Server use this index, when SQL Server use this index, where condition is based on department number. Okay, na? Then. So here SQL Server uses above index when where condition based on leading column of the index. Uses above index when where condition based on what? Leading column of the index. Leading column of the index. What is the leading column? Leading means first. Trailing means last. Leading means first. Trailing means last. What is the leading? Department number. First column in the index. That is called leading column. Department number. So compulsory where condition should be based on what? Where condition should be based on department number. Where condition should be based on department number. Then only it will use index. Like suppose here selects are from what? EMP where department number equals to 20. It will use index. It will not use index. It will use index. Index scan. Suppose here selects are from EMP where department number equals to 20 and what's that? Job equals to clerk. Then will it use index? Yes or no? Yes. Here where condition is based on leading column of the index. Selects are from EMP where job equals to clerk. Will it use index? No, it will not use index. It will use table scan. To use the index, compulsory where condition should be based on leading column, department number. In where condition is based on department number, then only it will use index. Otherwise, it will not use index. It will use table scan. Why? Reason is you can understand this if you know the structure of the index. Okay, na? Okay, then. Okay, now. Then. Now. But you'll understand why for this it will use index, for this why it will not use index, why it will use table scan. You'll understand this if you know the structure of the index. Okay, na? So like let's say like EMP table contains some data, jobs and like I'm not taking the data, you know the data. But when you create index will be created like this. What that is? Let's say what's that? 30 now. Okay. 20. Next one, what's that? 10. Next one, what? 30. 10th department, left side, what's that? 10th clerk. There is employee working for 10th department. 10th, what's that? Manager, star. There will be a star. What is the star is? Star is what's that? Address. Star is address. Next one, 10th department, what's that? Right side. 20th what sir? Clerk. Star comma star. Why 2 stars? Because there are 2 employees. There are 2 employees working for 20th department working as clerk. Next one, 30th department. 30th department. Left side. 30th what sir? Clerk. Star. 30th what? Suppose manager. Star. And 30th what sir? Salesman. Suppose 30th salesman. Star comma star. Star comma star. Okay na? Then so index is created like this. Okay na? What is this is? Root and intermediate. What is this is? Leaf nodes. Root and intermediate nodes are based on department number. Leaf nodes contains what? Department number and job. Root and intermediate nodes based on department number. Leaf node contains department number and job. So if you create index on composite multiple columns, index will be created like this. Root and intermediate nodes are based on first column. What is the first column? Department number. And the leaf nodes contains department number and job. Sir, you submit this query, department number equals to 20. Then tell me what it will do. Department number equals to 20. What it will do? 20 mass 20 is compared. Then go to left side. 20 10 is compared. Then go to right side. 20 clerk selected. 20 manager selected or not? Yes. Then so it will select. So 20 mass 20 is compared. Then go to left side. 10 is compared. Go to right side. 20 clerk 20 manager. So take these addresses and go to the table with the records from the table. Next, you said department number equal to 20, job equals to clerk. Then department number equals to 20, job equals to clerk. Then 20 is compared. Go to left side. 10 is compared. Go to right side. 20 clerk. Because you're asking 20 clerk, na? 20 clerk is selected. This is not selected. Only this is selected. 20 clerk. You take this what sir? Addresses and go to the table. Fetch the records from the table. Okay na? For this query also it will use index. Next one. What is the next query? Job equals to clerk. For job equals to clerk, will it use the index? Okay na? Sir, here once again. Actually, aim is to get the records from the table. To get the records from the table, what it requires? Address. Where is the address? Leaf node. But it cannot go to leaf node directly. It go to the leaf node through what? Root and intermediate nodes. Okay na? It has to get the records from the table. To get the records from the table, it needs address. Address is there in leaf nodes. It cannot go to the leaf nodes directly. It go to the leaf nodes through root node and intermediate nodes. But here, root and intermediate nodes are based on what? Department number. But given value is what, sir? Job. But using this job, can it reach to the leaf nodes? No. That's why it will not use what, sir? Index. It will use table scan. Understood? Then. Okay, na? So these queries will take the advantage of index, but this query will not take the advantage of index. Okay. Then. So we'll continue this Monday. Monday index will be completed and this SQL portion is also completed. Next TSQL programming is there.
next to the